have something that does the automation. Are you okay? And one of them is the intervalometer. All right. And the interval depends on the focal length, format size, flight height, velocity, a whole lot. Are you okay? All right. So yeah, I'm just touching on a few things that I find very important. All right. We have this wide angle camera, super wide angle camera, normal angle camera. I think we probably touched on it in the first lecture. I think we probably touched on it. Yeah. But a few things that we can, these are just pictures to show us really how these cameras really operate. Okay. So yeah, and a whole lot more on calibration, which I'm not really going to spend time on that. I'm not going to spend a lot of time on that. Okay, so when you take this material, you should know what to ignore and what to take. I'm actually doing up to the camera mount. Okay, so from this page going down, you don't really need that. From page 10 going down, I'm not really touching on that. Are you okay? So you can just look at it if you like someday, if you really think it will help you. Okay. Okay, one of the things that I also wanted to draw your attention to is the digital camera. Is that okay? The digital camera is not like the traditional analog film type of camera. Okay, it makes use of what we call charge coupled devices, or CCD. So please, you need to also come and read this part of it, page 24. Is that okay? Digital imaging devices. They make use of rectangular array of pixels. Is that okay? And then, of course, they store the value. When light interacts with these silicon elements, then they can record the amount of, radiation, whatever, amount of energy that is incident on it. So your phones, all the phones that we are using have these semiconductor electronics as part of it that allow us to convert the light that is coming to the phone into values, certain values, but they are a grid, an array or a grid. So every picture is also made up of, a grid of some small squares, and these squares are the pixels. If a pixel stands for picture elements, so I want you to take note of that. Come to this page and read a little bit more about all the digital things that are here. Okay, digital frame camera. Okay. And etc. Are you okay? This is how they work. Understand the fact that we have row and columns of what? Pixels making up that. Okay, so yeah, a few things that can be said about digital cameras, and there's a little calculation here that I think we can all spend time looking at. Maybe if you have time, we come back at it. But there's a lot to talk about. So I'll leave this one here for now. I want to waste time on that. We are going to talk about stereoscopic viewing. Okay, so stereoscopic viewing. Where are you? Okay, so that's the material. All the materials that I'm using are actually from I have a few websites that I've created that I've been using for years. I mean, I can see I've been using it for years because it's been a long while since I actually uploaded them there. And if you go to franzi.ulas, I don't know if you've been there before, .com, then you can actually access this material we are looking at right now. But obviously, I've been dumping it on your WhatsApp page as well, the group page. So you are good to go. All right. So stereoscopic viewing. Stereoscopic viewing, the opposite of that is monoscopic viewing. Is that okay? So mono is 1, stereo is 2. Is that okay? So basically, it starts with the basic concept in stereoscopic viewing is what we call depth perception. Is that okay? Depth perception. So depth perception, depth is height. That's another word for depth is height. Okay, or elevation, more or less. Yeah. I mean, how deep something is, really. Are you okay? And how deep something is really points to its elevation. So in a way, elevation, height can be related to depth perception. So when we see how far something is from us, that's depth perception. Are you okay? And so when we look, we use the word height, elevation, then we are thinking about vertical. Are you okay? Vertical height, but this could be just horizontal, but we could always look at it in the vertical as well. Okay, so the word depth there, we should take note of, why that is being used. Okay, so what's binocular vision? Binocular, ocular is eye, and then bi is two, so two eyes. Is that okay? All right, so we're saying that binocular vision is capable of viewing. If you are capable of viewing with both eyes simultaneously, then you have what we call binocular vision. Okay, so binocular vision is viewing with two eyes at the same time, simultaneously. Is that okay? At the same time. All right, so monocular vision, viewing with only one eye, that's monocular vision. All right, so monocular viewing is judging depth with one eye. So we look at one, if I look at something with just one eye, that is monocular viewing. When I look at something with two eyes, what is the effect? Are you okay? What difference does it make? We try to perceive depth. We try to perceive that, okay, how far is that chair from me compared to, the door over there, okay? Or if you look at what we have on the screen, how far is the building from us compared to, this is looking more like a stadium, are you okay? Some sort of podium, are you okay? Where some sporting activity takes place. Which one of them is closer and why? Are you with me? So there's a way to perceive that, and one of them is the relative size of objects. So when objects are close, they tend to be small, larger, and then so that we are deceived to think that they are larger. It's not like we are deceived, but that they appear larger. Is that okay? And then when objects are far, then they tend to be smaller. So I remember there's this diagram that, oh, come on, why Microsoft, what's happening today? Okay, let me try if it works for the last time, then I'll probably give up on it. This board really, really helps. Okay, so let me use this. So growing up, I liked some arts, let me say, as a child, as a kid, and to draw buildings at a village. This is one of the easiest drawings that you could do. Okay, but the trick is that as you draw more buildings, you hide them behind, okay, each other, and then to say that, like you are getting farther and farther away, and then you reduce the size of the buildings, and then as you do that, you create an effect of actually having, some kind of road going through. And the reason why the road is narrowing at this point is simply because it's far away, and it's larger here because it's closer to you. Okay, so relative size of objects tells us how close they are. And we can also look at the hidden objects. So this building is actually hiding from this one. And so it makes this one, the first one, building A, closer, okay, than building B. So there are so many ways of determining if objects are, how far objects are from us. Also shadows, okay, how do shadows tell us whether something is close or far? Okay, how do shadows tell us? We can look at the sun, for example. The shadows that the sun casts can give us an idea, okay, of where the sun itself is, etc. Okay, all right. Difference in focusing. I mean, if an object is far, then you have to really change the focus to get it when you use a camera. So these are a few ways of determining, how the depth of how far objects are from us. Firstly, so if you're talking about depth perception, then it's only one thing that comes to mind. We the eye becomes a basic, organ, the human eye, that allows us to perceive depth. Is that okay? So the camera is actually always compared to the eye in terms of function. Okay, so light comes into the eye through the pupil, etc., goes through the lens. The lens focuses it on a certain sensitive area. Are you okay? Around the retina, close the retina, and then we are able to now perceive that through the optical nerve, so that we have a signal, a message being sent to our brain for interpretation. Are you okay? So yeah, we have an opening, like it's got a shutter, it's got everything, a diaphragm, etc. And then so that is how the eye works. It's very important for us to understand that. Okay, so let's move on. How do we actually perceive that stereoscopically? The way we are able to, perceive that stereoscopically, in other words, what it means is that we can perceive that. The reason we have the two eyes is so that we can perceive how close and far objects are from us. Are you okay? So the left eye is shown here, and then the right eye on the right hand side. Is that okay? All right, so it's very simple. The left eye and the right eye sustain an angle of phi A and then phi B on the object B, and then the difference between the angle phi B and phi A now becomes, the judgment that helps us to judge that one object is close or far. So let's assume that we don't have, any of these means mentioned here. Relative size of objects, hidden objects, nothing is hidden, objects are not changing in size. Are you okay? No shadows, nothing. How do we tell if objects are really close? By stereoscopic means. We make use of the so-called parallactic angles. Are you okay? So the parallactic angles, they help us to determine. So they are the phi A and then the phi B. Okay, so this angle here and that angle, they help us to determine the difference between them. Are you okay? Now the distance between the two eyes, we want to call it the eye base, and everyone has their own eye base. I don't know if I have a normal eye base, or I don't have very large eyes, but you can take a ruler and then just measure the distance between one eye and the other. I've seen someone with eyes so close, they're very, sexy, you know what I'm saying? But yeah, it's not really constant value. The eye base is not a constant value. The eye base is not a constant value. You have to know that. The eye base is not a constant value. Okay, so there you go. So the distance between the two objects is actually given by, of course, A from here to here, minus from here to there. Is okay. And then the perception is we perceive via the parallactic angles. Easy peasy. I think we can just move on, talk about something else. All right, so what happens when we view photos stereoscopically? What happens? Are you okay? The same principles are used. Is that okay? All right, so as A moves to A prime, so here referring to these points here, A to A prime, image marks. So now the images tend to appear, are you okay, on here. So A prime and A prime 2 on transparent medium above the closer. So the same principles are used. Are you okay? If you're able to look at this one image here, one image there, then we sustain the angle, the parallactic angle is sustained. Are you okay? And the separation then creates, that effect of 3D. Are you okay? In other words, we can see the objects there, but then now we can also appreciate how high or low they are. If you actually look through a stereoscope before, you know what I'm talking about. Okay, So the principles of just looking with the two eye at an object and sustaining it a certain distance. As we walk around every day, you don't actually appreciate the parallactic angles because, I mean, everything is hidden. You know, you can always tell something is behind something. And so one is closer. Okay, but then it's actually happening as you go. All right, so let's move on. Let's talk about something else. Okay, so here, if you don't even understand what I'm talking about, you can look at the diagram on the board. I think there's more in there. Right, you can see that the building has, the top of the building is at A. And so A, somewhere there. And then the bottom is B. Are you okay? All right. And so on the photograph, we are having the building slanted on it. Is that okay? So the same thing is happening on the left side of the photograph. Is that okay? And the angles that are sustained become, you know, different, because if you look at the angle here and the angle there, they're not going to be the same. Are you okay? And so we can have that effect. Is that okay? So now we have, we call this one the exposure station. All right, exposure station. This is where the pictures were taken. So exposure station 1, exposure station 2. This is the fly direction. You're flying from left to right. Always remember that on any sheet of paper you're looking at, if you want to depict this, the direction is left to right, and that is the x-axis. Later we'll find out. Okay, we do a lot of this in this class, so don't worry. Talk about this. Okay, the distance between the first exposure station and the second exposure station when we take photographs is called the air base. I don't know if you still remember these things. I think it's not been too long since some of you did some photogrammetry, so I think you should appreciate this. Okay, also there's what we call the flying height, which is this, the distance of the exposure station from the datum. Okay, so h is the flying height. Okay, and this line here is the datum. You can assume this datum, or you can actually assume, you can use, for example, the MSL for it if it's necessary for you to use that, the mean sea level. Are we okay? All right, so this setup here, immediately you see this, you should know the trick. What we are trying to do is to extract heights of objects. Anytime we do stereoscopic viewing, anytime we do, we capture overlapping photographs, the trick is that we want to actually get to the height of the object, because I've explained to you that depth has got something to do with what? Height. Depth has something to do with what? Height. Remember that. So depth perception and stereoscopic viewing of photos definitely has everything to do with determining the height. Okay. All right. So viewing photos stereoscopically, I mean, if you've done it before, you know how to. But if you haven't, then a few steps you can take. A few steps. Take note of a few steps. Place the photos laid on the table so that your left eye sees the left image and the right eye sees the right image. The photos have to be aligned, basically. Is that okay? And then now, when you actually look at the two images together, like magic, you begin to see the so-called stereoscopic model. Okay, the stereoscopic model. So your left eye should see the left photo, your right eye should see the right photo, and then there you go. So I don't need to draw this diagram again, but obviously you can see that the distance between the two eyes, okay, I told you that is the air base. This is the eye, okay, these are the two eyes, left eye, right eye, if you like, depending on where you stand. Okay, now this is virtual. Everything you're looking at here is a so-called model. And if anytime you do photogrammetry and you come across this word model, it's really not real. It's not real. And that is why it's called a model. I like this one. It's not real. That's why we call it the model. Are you okay? You look at it, you see something. It seems as if it's there, but it's not really there. It's a representation of reality. It's a representation of reality. Is that okay? But the beauty of this is that you'll be looking at the ground like as if you were really flying in the sky. I think this one, everyone should have this experience. If you haven't, I think we can arrange for that and let you have that experience. You can also use what we call there's an image separation method online where the two images are actually separated into two different colors. Are you okay? And then you can wear glasses. Are you okay? And then look at the image, and then the two images are then separated, and by their separation, we can now have the model formed. You can see the model. Is that okay? All right, I'll tell you very soon exactly what it is. I've been doing a lot of I'm saying things, so it's gone. But there's a method for doing the anaglyph. That's the word, anaglyph. So we can use an anaglyph, wear anaglyph glasses, and download images online, and then begin to see this model without necessarily, but then even getting stereo pairs online is not easy. The last time I tried, it's not easy. But I have a few ones that I will show you. I'll give to you, and I'll ask you to do some work on it. Okay, very simple stuff. Is that okay? That you do for me. All right. So look at this statement here. I will expect you to, understand it. And then anytime I ask you a question on it, I know you know it already, but if you know it, then you have to prove it. The brain judges the height of the building from differences in the parallactic angle. Remember that this is the second time talking about it. So the parallactic angles are actually here, going there, over there. The angles formed between these two lines here. Okay. All right. So yeah, one is smaller than the other. The one that is far is smaller than the one that is closer. For example, if there's an object, if the building were that high up, then you can see that the parallactic angle will be this one. So phi h. Are you with me? So let's kind of think outside the box. All right. So there you go. When this session ends, please let's rejoin with the same link and do some more talking. All right. We have 9 minutes and then this session will end. All right, so I think most of you know this. I mean, you've seen this before. If you haven't, take note of it. The stereoscopes, are you okay? They allow you to actually look at the photos stereoscopically. Of course, they are stereoscopes. So what else are they going to do? So for pocket stereoscopes are there. They can be folded. You can have the mirror stereoscopes, which actually have mirrors, which have been arranged in 45-degree angles. Is that okay? That allow you to also look through a binoculars. So there's a pair of binoculars available for you to actually look at it. So they contain some lenses as well in there so that we can even magnify and see the image better. Okay. So the use of stereoscopes is what we are looking at here. So we have to align them. It's very important that we align the photographs. Are you okay? All right. So let's look at this statement. Accurate and comfortable stereoscopic viewing requires the eye base, the line between the centers of the stereoscope lenses and the fly line, to be parallel. Is that okay? So you have to align your eyes. Your eyes can be somewhere, and then you have the, the centers of the stereoscopic lens also another place. Are you okay? They have to be together. And the line between your eyes, joining the centers of your eyes, should be parallel with the flight line. Are you okay? And I think we've talked about the flight line. I'm going to indicate the flight line again. That is what you're looking at here. This line here. It goes. That's where the aircraft is actually traveling in that direction. Are you okay? All right. Now, what are the things you are seeing here? It's very important that I explain them. Okay, so O1 on the left photograph has a corresponding image O1 prime in the right photograph. All right. And then O2 on the right photograph has O2 prime on the left photograph. It's assumed that the two photographs have a common overlap region. Okay, so it's assumed that whatever you are seeing within this region, you can almost see it also here. And that is why we are seeing an image of, you know, on this one appearing in the other. Are you okay? All right. So O1 is only appearing here because almost everything you are seeing within this region is actually also visible in that region. Okay, creating the so-called overlap area within which we can observe the same objects from the two different eyes subtended. So, but here, this view is actually a vertical, a planimetric view. We are looking at it from the top. Is that okay? All right. Now, point A and A2, these represent points on the ground. Are you okay? So, point A and then A2 represent points on the ground. Okay. All right. Okay, great. The word conjugate means like, I don't know how to call it, like a representation of, okay, the principal point. So the conjugate principal point, that actually, when we say that, we are really referring to the corresponding principal points. Are you okay? All right, great. Let's see if we can talk about something else. Okay, now what is Y parallax? Y parallax is not wanted. We like to talk about X parallax, but we don't want to talk about Y parallax. Why? Y parallax is an error. Okay, so the X parallax is in a certain direction, the direction of the X. Okay, so if you have a single photo like that, okay, and then you have another one. So this is the X axis. Okay, so naturally the two photos are separated in the X direction. All right, the two photographs have to be aligned in such a way that their centers lie on a straight line. Okay, so we don't want a situation where one photo is like this and the other is like that. Okay, when that happens, then it means there's an error. All right, and this error will make sure that you will not be able to form the so-called model, stereoscopic model. Okay, so parallax is really the relative movement of an object due to the movement of the observer. We will talk about this again. All right, but then when we move in the fly direction, that is normal. We don't have an issue. It's normal. This one is normal. We like it. Okay, we are happy to be having that big end. That's what we really kind of paid for, that we'll be moving in this direction. Okay, but here there's an error here. We don't want it. We don't want this. Okay, so this is parallax. This is Y parallax. And it will be showing up a lot. We'll be talking about this a lot. Parallax. But parallax in the X direction is normal because we intentionally are flying the plane in a certain direction. So who are you to complain that? Why are we moving it? Why are we having a shift in that direction? But the shift in the Y direction is a big problem. Okay, let's go back to it then. So the Y parallax, slight amounts of the Y parallax cause the eye strain because your model is not forming because it's not aligned. And then excessive amounts prevent stereoscope. In fact, you won't even see the model at all. You'll be looking at it like that and be seeing anything. So it's important that we align the two photographs such that their centers lie on a straight line. The causes of why parallax are that the photos are improperly oriented, as I said. Also, you probably have unequal flying height between the photos. Okay, or you have a tilt in the photography. I wish my whiteboard was really working. At the moment, I'm using my mouse to draw in some way. We don't want that. So if you have, oh, come on. Okay, no problem. So if you have a situation where you have the flying heights like that, and then here you have it like that, and there's a change in flying height, you can also experience this Y parallax. In fact, it's a no-no. You don't even want to have this situation at all. You don't need it. Is that okay? All right. So this lecture will end very soon. When we come back, you can ask a few questions. We continue from where we left off. Is that okay? We use the same link to rejoin, and then let's talk a little bit more about parallax, and then see how far we go. Stereoscopic viewing, etc. Okay, it's just fun. I think talking about photogrammetry is like telling a tale, a story. Are you okay? I think we should just enjoy it. Especially if you already know it, I think you should just enjoy it and score a very high mark in photogrammetry. It's okay. That is the only excuse you have for this course. You need to do well. Okay, so like I said, it will end soon.